On May 26, 1940, at the White House in Washington, D.C., radio technicians fine-tuned microphones as President Franklin Roosevelt prepared for a momentous address. His speech would resonate through a country still grappling with the economic aftermath of the Great Depression and striving to recover from widespread unemployment affecting both urban and rural areas alike. "We must manufacture 50,000 aircraft within the next year," Roosevelt boldly proclaimed. This ambitious goal aimed to bolster democracy's defense. In Berlin's Reichskanzlei, German military officials gathered around transcripts of Roosevelt's speech with a combination of amusement and skepticism. They scrutinized the figures closely before presenting them to Adolf Hitler. His advisors assured him that it was merely American propaganda intended to instill fear, pointing out that the United States had produced fewer than 3,000 military aircraft the previous year. Such an achievement, they argued, was nothing more than a fantastical impossibility designed to deter German advances. Hitler agreed with their assessment, finding no merit in Roosevelt's claims given America's limited industrial capacity and lack of experience in military production. In reality, American factories were primarily geared towards automobile manufacturing rather than aircraft production, and the workforce had little knowledge or expertise in building warplanes. Nevertheless, Roosevelt had pledged to surge output by over 1,600% within a year. The German High Command viewed this as nothing more than bluster from a nation incapable of transitioning swiftly into becoming a formidable military force. Unbeknownst to them, they were about to witness one of the most remarkable industrial mobilizations in history. Roosevelt's reference to America as a sleeping giant referred not to its military prowess, but rather to its vast industrial capacity. The automotive plants in Detroit, the shipyards along the coasts of California and Oregon, the steel mills of Pennsylvania, and the expanding aircraft manufacturing facilities nationwide would soon unleash productivity on an unprecedented scale that defied conventional notions of warfare. German strategists had meticulously analyzed military strength, planning for tank divisions and infantry units. However, they had overlooked one critical factor, the potential that American factories were about to unleash. The Japanese attack on Pearl Harbor in Hawaii on December 7, 1941, thrust America into global conflict. Yet even as the military scrambled to respond, a far more significant transformation was quietly unfolding across the nation's industrial landscape. This conversion had actually begun months earlier and was accelerating with each passing week. Assembly lines were being dismantled and reconfigured, factory layouts redesigned, and workers retrained. The greatest economic metamorphosis in modern history was well underway. William Knudsen, former president of General Motors, was appointed by Roosevelt to oversee the industrial mobilization effort. In early 1941, Knudsen made a crucial phone call that would alter the course of the war. He contacted K.T. Keller, then president of Chrysler Corporation, and asked, "Can Chrysler produce tanks?" Keller's response was straightforward. "I don't know. Although I haven't seen one myself, if you provide the specifications, we can figure it out." Construction on what would become known as the Detroit Arsenal tank plant commenced within weeks. Architect Albert Kahn, renowned for his expertise in industrial design, drafted plans for a facility that was unprecedented at the time. The main building covered an area of 113 acres. Some sections featured walls up to 3 feet thick made of reinforced concrete, designed to resist aerial attacks. This assembly line would revolutionize the production of armored vehicles. However, what truly set the Detroit Arsenal apart was its speed in construction and operation. Work began in winter 1940-1941. On April 24, 1941, the first M3 medium tank rolled off the assembly line even before construction had fully finished. The workforce erupted into cheers as the tank, complete with operational guns, fired them and crushed simulated obstacles during a nationwide broadcast demonstration. This efficiency amazed military observers from Allied nations. British tank production involved extensive hand-fitting and customization, making each vehicle unique. Although German methods were more standardized than those of the British, they still heavily relied on skilled craftsmen and time-consuming assembly processes. The Detroit arsenal brought true mass production techniques to armored warfare. In 1941 alone, Albert Kahn designed over 20 million square feet of defense plants. His innovative factory designs applied automotive production methods to military equipment. Wide-open floor plans facilitated the smooth movement of components via overhead cranes between various stations. Assembly lines seamlessly integrated into primary manufacturing processes, creating a meticulously synchronized workflow that astonished conventional military producers. By December 1942, the Detroit arsenal shattered all previous monthly records with an impressive output of 1896 M4 Sherman tanks. This production rate surpassed Germany's total tank output across all its facilities during the same month. The plant ran continuously around the clock, employing 3 rotating shifts of workers, many of whom were women who had recently entered the workforce for the first time. In September 1942, President Franklin D. Roosevelt and First Lady Eleanor Roosevelt toured the facility. They observed tanks being assembled through a series of meticulously coordinated steps along the production line. What they saw was an unprecedented level of industrial coordination. Throughout World War II, the Detroit arsenal produced 22 234 tanks, representing roughly 1/4 of all American-made tanks during the conflict. The site transformed from farmland to the world's leading armored vehicle factory within 2 years. Operating with remarkable efficiency, components sourced from suppliers across the Midwest arrived at organized warehouses and were then moved to assembly points according to strict schedules. The production line operated non-stop, with each station handling specific tasks such as welding whole sections or installing engines and transmissions. Electricians installed communication networks, while armorers attached weaponry. At the production line's conclusion, fully assembled tanks emerged under their own power, rolling onto railroad flat cars for delivery to ports and training sites. This metamorphosis extended beyond tank fabrication. It permeated Michigan's automotive sector as companies rapidly pivoted toward wartime manufacturing with unprecedented speed. In Willow Run, Henry Ford's grand vision began to materialize. The bomber plant was set to become the most ambitious aircraft assembly facility ever conceived. Earlier in 1941, Charles Sorensen, Ford's vice president for production, visited Consolidated Aircraft in San Diego and witnessed a production process that seemed outdated even compared to pre-war standards. There were no blueprints, no precise measurements, and no standardized parts. Each plane was essentially handmade. Sorensen observed workers custom-fitting components, hammering sheet metal into rough alignment, and making individual adjustments on every aircraft. He expressed his frustration openly to his hosts. "This is how we built cars 35 years ago at Ford." That evening in the Coronado Hotel, Sorensen sketched a groundbreaking idea on hotel stationery. He envisioned an enormous factory stretching 1 mile in length and 1/4 mile wide. The B-24 bomber would be divided into major assemblies, such as wings, fuselage sections, tail units, and engine mounts, each built concurrently along separate subassembly lines. These elements would then come together on a central assembly line where bombers were assembled with the efficiency and pace of an automotive manufacturing process. Sorensen's initial sketch, approved by Edsel Ford and his team early the following morning, laid out the groundwork for Willow Run, a facility that was so ambitious it immediately earned the nickname Will It Run from doubters who questioned whether Ford could actually deliver on such bold promises. Construction commenced in spring of 1941. The federal government invested $200 million, while Ford provided engineering know-how and management expertise. The resulting plant was unprecedented in size, spanning over 3.5 million square feet under one roof. It featured an assembly line stretching 1 mile long with a 90-degree turn halfway through to prevent it from extending into Wayne County, where property taxes were higher. This L-shaped factory became the largest single room in the world at that time, but constructing the facility was simpler than mastering bomber production. Ford's engineers realized that aircraft manufacturing required far more precise tolerances compared to car manufacturing. A car door that was slightly off by a 1/16 of an inch might close poorly, whereas a similar deviation in an airplane wing could result in serious aerodynamic issues. The first year presented numerous challenges. In 1942, Willow Run managed to produce only 56 B-24 bombers. Critics were quick to pounce, noting that the facility had cost $200 million and employed 20,000 workers, yet was producing fewer aircraft per month than the consolidated San Diego plant had been making before the war. Editorial pieces in newspapers questioned whether mass production techniques could ever be successfully applied to complex military planes. Some aviation experts argued that bombers needed skilled craftsmen rather than assembly line workers. Ford's reputation hung in the balance, as the company famous for revolutionizing automobile production with the Model T and moving assembly lines was struggling on its most ambitious project. However, Ford continued to push forward. Technical experts overhauled jigs and fixtures. Employees underwent extensive training sessions. Production processes evolved through continuous experimentation and refinement. Quality control measures were put in place. By mid-1943, these changes had been fully integrated into operations. On November 3, 1943, the 1,000th B-24 aircraft was completed at Willow Run's assembly line. This milestone was marked by a celebratory event featuring military and government officials alongside thousands of workers. More crucially, production rates were increasing dramatically. By early 1944, the facility was running at its maximum capacity. In April 1944, the plant manufactured 453 bombers within 468 hours. This equated to one fully assembled aircraft every 63 minutes. The pace was intense and unprecedented. The workforce at Willow Run mirrored the broader societal changes occurring across American industry. By the close of 1943, there were approximately 42,000 employees working at the plant. Women made up a substantial part of this labor force. These women had not previously worked in factories before the war. They were homemakers, teachers, secretaries, and store clerks who responded to the call for defense workers. They learned how to rivet aluminum sheets, install electrical systems, and operate precision machinery. The government initiated extensive recruitment campaigns aimed at enlisting women into industrial roles. Rosie the Riveter emerged as an emblem of female war workers. Despite the propaganda posters, women were acquiring sophisticated technical abilities and ensuring that production schedules met the requirements of military success. The extent of social transformation was truly remarkable. In 1940, unemployment 14.6%, but by 1944 it had plummeted to just 1.2%. Full employment had been achieved. Even more notably, around 6.5 million women joined the industrial workforce during the war years. They took on roles such as welders, machinists, crane operators, inspectors, and supervisors, positions that were traditionally reserved for men before the conflict began. This shift was not confined to gender boundaries. African Americans also encountered previously unseen opportunities in defense industries. The Great Migration intensified as black workers moved from rural southern states to industrial centers like Detroit, Los Angeles, Portland, and Seattle, seeking jobs in war-related production. Although discrimination still existed, the dire need for labor opened doors that had been shut prior to the war. The statistics reveal a profound transformation extending well beyond military manufacturing. Over 24 million Americans relocated during these years, pursuing work in defense industries, military service, or thriving war-related businesses. Major cities experienced rapid population growth due to this influx of workers, leading to severe housing shortages. Government agencies raced to construct temporary accommodations for defense employees, resulting in the proliferation of trailer parks, dormitories, and prefabricated houses near large factories. The social tapestry of America was fundamentally altered by the demands of industrial mobilization. Production at Willow Run continued to escalate throughout 1944 and into early 1945. By June 1945, when the final B-24 rolled off the assembly line, the facility had manufactured a total of 8 60-85 bombers. Furthermore, Willow Run manufactured around 893 knockdown kits. These were fully disassembled bombers that could be transported overseas and reassembled close to combat areas. The knockdown kits addressed a significant logistical issue. Transporting bombers across the Atlantic required vast amounts of fuel and exposed aircraft to weather-related damage and mechanical issues. Shipping disassembled bombers by cargo ship, followed by assembly at forward bases, proved more efficient. The economic impact of Willow Run was equally remarkable. In 1942, the cost to produce a B-24 was approximately $38,000 per aircraft. By 1944, through enhanced efficiency and mass production methods, this cost had dropped to $137,000 per aircraft. This 42% reduction in costs achieved while significantly increasing production speed and maintaining quality showcased the effectiveness of Ford's production system applied to military equipment. Sadly, Edsel Ford, who spearheaded the Willow Run project from its inception, passed away on May 26, 1943, at the age of 49. Stomach cancer, intensified by the stress of managing the bomber plant during its challenging early stages, claimed his life just 6 months before Willow Run reached full production capacity. Although he did not live to see his vision fully realized, his leadership played a crucial role in transforming the struggling facility into the most productive bomber factory in the world. While tanks and aircraft garnered public attention, another industrial marvel was unfolding at American shipyards. The Liberty Ship program exemplified mass production applied to shipbuilding on an unprecedented scale. Prior to the war, American shipyards operated at a leisurely pace. Constructing a cargo vessel typically took more than a year. Skilled shipbuilders hand-fitted components, and riveting was done by specialized teams. Each ship was essentially custom-built. The U-boat campaign by Germany in the Atlantic altered everything. British and American merchant vessels were being destroyed at a rate that surpassed the capacity of conventional shipbuilding techniques to replenish them. By 1941, the situation had become dire. Britain relied heavily on Atlantic convoys for essential supplies such as food, fuel, and military equipment. If Germany triumphed in the tonnage war, it could starve Britain into surrender irrespective of other military outcomes. Henry Kaiser, a construction engineer with experience in building dams and highways but no background in shipbuilding, proposed an innovative solution: standardized designs, prefabricate components, use welding instead of riveting, and apply mass production techniques to shipbuilding. Traditional shipbuilders were skeptical, arguing that the craft required for shipbuilding could not be replicated through mass production. Kaiser disagreed. He believed that breaking down ship construction into standardized steps, training workers in specific tasks, and coordinating the assembly of prefabricated sections could significantly accelerate production. The government, desperate for tonnage, gave Kaiser a chance to prove his theories. The Liberty ships were based on a modified British steamer design intended for rapid construction. Each vessel measured 41 feet in length with a beam of 57 feet and had a cargo capacity of 10,000 tons at a cruising speed of 11 knots. The design was intentionally simple, without unnecessary features or architectural embellishments, focusing solely on functionality as a quick-to-build and cost-effective cargo ship. Each Liberty ship required 250,000 parts produced in factories across the country, which were then transported to shipyards where they were assembled into major sections such as the bow, stern deck houses, and holds before being welded together. Approximately 114 miles of welds held each Liberty ship together. This equated to approximately 600,000 feet of welding per ship. The sheer scale of the welding effort was overwhelming. Kaiser constructed shipyards in Richmond, California, and Portland, Oregon. Other companies also built Liberty shipyards in Baltimore, Houston, and on both coasts. At the height of production in 1944, American shipyards were launching 3 Liberty ships daily. One of the most notable records was set at Kaiser's Richmond yard in November 1942, when the SS Robert E. Perry was launched just 4 days, 15 hours, and 29 minutes after laying its keel. This remarkable achievement was made possible through extensive prepositioning of materials and served primarily as a publicity demonstration rather than standard production. The ship still required significant post-launch fitting work to be fully operational. Nonetheless, the demonstration illustrated that dramatic acceleration was attainable with proper organization. More indicative of typical production times were those achieved by 1943 and 1944, when ships that had previously taken 244 days to build in early 1941 could now be completed in just 39 to 42 days. This six-fold improvement was the result of continuous technique refinement, better supplier coordination, and increasingly skilled workforces. By the end of World War II, American shipyards had produced a total of 2 710 Liberty ships across 5 years from 1941 through 1945, involving 18 different shipyards. Despite their utilitarian appearance and modest performance capabilities, these vessels played a crucial role in the Allied victory. They managed to cross the Atlantic in sufficient numbers to support British resistance efforts. They transported vehicles, supplies, ammunition, and fuel that were essential for sustaining Allied forces in North Africa, Italy, and France. Post-war, many Liberty ships continued their service in merchant fleets worldwide. Some remained operational into the 1960s and early 1970s. Their robust yet straightforward design demonstrated exceptional durability, but their real importance lay in proving that even intricate products such as ocean-going ships could be mass-produced efficiently by workers with minimal training through effective organization and systems. The shipbuilding effort in the United States during World War II went far beyond just Liberty ships. A total of 577 merchant vessels of various types were constructed, including oil tankers, troop carriers, refrigerated cargo ships, and specialized crafts. Simultaneously, the U.S. Navy was constructing warships at an unprecedented pace. This included aircraft carriers, battleships, cruisers, destroyers, submarines, and smaller vessels that emerged from naval shipyards in large numbers. Additionally, American shipyards manufactured around 89,000 landing craft of different types. Among these were the renowned Higgins boats designed for beach landings during the invasion of Normandy. Andrew Higgins, a boat builder in New Orleans, had created a shallow, draft vessel with an innovative bow ramp to navigate Louisiana's swamps and marshes. Recognizing its potential, the military scaled up this design and armored it for use in amphibious assaults. Higgins Industries ultimately produced over 20,000 landing craft, significantly enhancing Allied capabilities. Beyond the well-known achievements, American industry also saw mobilization in areas that received less public recognition but were equally essential. Factories churned out 93,000 artillery pieces ranging from anti-tank guns to large howitzers. Tank production surged to about 86,000 units, an enormous leap from pre-war levels when American tank manufacturing was minimal. More than 2 million Army trucks rolled off the assembly lines, providing mobility that enabled rapid operations for Allied forces once they landed in Europe. The Red Ball Express, a truck convoy system that supplied Allied armies advancing across France during summer and fall 1944, relied entirely on these American-built vehicles. The scale of America's wartime production becomes evident when comparing it to enemy capabilities. By 1944, U.S. industries were producing roughly 2/3 of all Allied military equipment. This meant that American factories supplied not only American forces, but also substantial portions of the British, Soviet, French, and other Allied militaries. Lend-lease shipments transported American-made tanks, aircraft, trucks, and supplies to Allied nations. While the Soviet Union produced impressive quantities of its own equipment, it heavily relied on American trucks, food, and raw materials during this period. Britain's industrial capacity was stretched to its limits and highly susceptible to aerial bombardment, making it heavily reliant on American manufacturing for a variety of specialized goods. Transforming American industry involved more than just building new factories. It necessitated an unprecedented level of collaboration between the government and private enterprises. The War Production Board, which came into existence in January 1942, managed the allocation of raw materials, set production priorities, and resolved conflicts arising from competing demands. Resources such as steel, aluminum, copper, and rubber were distributed based on military requirements. Civilian manufacturing was reduced or halted entirely for many products, with automobile production for consumer use ceasing in February 1942. The last civilian car rolled off the assembly lines and did not resume until after the war's conclusion. Factories that had previously manufactured refrigerators, washing machines, and other household items switched to producing military goods. A rationing system was implemented for civilian consumers, limiting access to gasoline, meat, sugar, coffee, and many other commodities to ensure sufficient supplies for the military. The story of R.G. Eleno exemplifies the entrepreneurial creativity that flourished during this period. Prior to the war, Eleno was an inventor and manufacturer of earth-moving equipment known for producing innovative scrapers, dozzers, and other heavy machinery. During the conflict, Leono's factories supplied around 70% of all earth-moving equipment utilized by Allied forces. Among his innovations were enormous scrapers capable of moving massive quantities of earth rapidly, facilitating quick construction of airfields, roads, and fortifications. Throughout his lifetime, Lowe held approximately 300 patents, with 78 granted during the war years alone. His machinery played a critical role for military engineers in building infrastructure essential to modern mechanized warfare. The technological advancements made during this period had a profound impact on post-war industry and society. Following Japanese conquests that severed natural rubber supplies from Southeast Asia, synthetic rubber production expanded rapidly and became standard for automobile tires and numerous other applications. The development of radar technology by the British, later enhanced through American mass production, dramatically improved aviation safety and weather prediction. Breakthroughs in metallurgy, chemistry, and manufacturing for military purposes also translated into civilian applications. The proximity fuse, designed to increase the effectiveness of anti-aircraft weaponry by detonating shells near targets instead of requiring direct hits, later found use in industrial automation and control systems. One of the most enduring impacts was on management methods and organizational structures. Coordinating large-scale industrial operations, managing intricate supply chains, and ensuring quality across numerous factories imparted lessons that profoundly influenced American business practices for decades. Techniques refined at Willow Run and the Detroit Arsenal became models studied in business education programs. The production strategies, inventory control measures, quality assurance protocols, and workforce training initiatives developed during wartime shaped post-war manufacturing processes in various industries. The scale and complexity of military production necessitated management innovations that might otherwise have taken years to emerge under peacetime conditions. The social dimensions of mobilization were significant and enduring. Working in defense factories provided millions of Americans with new skills, increased confidence, and elevated aspirations. Women who had mastered complex industrial tasks during the war often felt unfulfilled returning to traditional domestic roles when men returned from military service. Although many women did leave factory work after their husbands' return, their wartime experience highlighted capabilities that were hard to overlook. The roots of the women's movement in the 1960s and 1970s were partly sound during wartime factory jobs where they demonstrated that with proper training and opportunity, they could excel in any role. For African American workers, the wartime period was equally transformative. Established by executive order in 1941, the Fair Employment Practices Committee made discrimination illegal in defense industries. Despite inconsistent enforcement and ongoing discrimination, a principle had been set. Black workers gained access to skilled jobs, higher pay, and union membership previously denied them, contributing to the war effort while enduring discrimination sharpened demands for civil rights. Veterans returning from fighting abroad against fascism were less willing to tolerate racial oppression at home. The civil rights movement that would reshape America in the 1950s and 1960s drew inspiration partly from wartime experiences of what was possible when all citizens could participate equally. The economic metamorphosis was equally striking. An economy plagued by persistent unemployment throughout the 1930s reached full employment in 1943. Total industrial output nearly doubled from 1940 to 1944, marking the swiftest economic expansion in American history. Gross domestic product surged from roughly $100 billion in 1940 to over $200 billion by 1945. This growth was almost entirely due to war production, but showcased productive capacities that would fuel post-war prosperity. The infrastructure established during the war, including factories, power plants, and transportation networks, continued to benefit the economy for many years. The challenge of reconversion from military to civilian production turned out to be less daunting than anticipated. Planning for this transition began as early as 1944. The War Production Board had to navigate complex decisions regarding when to release industries from war contracts. Releasing them too soon could jeopardize the supply of military goods, while delaying the process might hinder the post-war economy's recovery. Balancing these needs required careful management but was ultimately successful. Tank production ceased abruptly with Germany's surrender in May 1945, and aircraft production ended shortly after Japan's capitulation in August. The cancellation of war contracts led to temporary unemployment as defense workers were laid off, yet the shift to civilian production proceeded swiftly. Factories that had manufactured tanks reverted to producing automobiles. Accumulated demand for consumer goods during years of rationing spurred rapid economic recovery. Americans who had saved money due to wartime scarcity suddenly found themselves with significant purchasing power. The automobile industry, which halted civilian vehicle production in early 1942, now faced an overwhelming market demand. Following World War II, housing construction experienced a significant surge as veterans began starting families and settling down. The GI Bill played a crucial role by offering veterans educational opportunities and affordable mortgages, which in turn spurred economic growth. American industrial might profoundly shape the post-war world order. The Marshall Plan, instrumental in rebuilding Western Europe, was made possible due to America's ability to meet both its own needs and those of its war-torn allies. U.S. Factories supplied machinery, vehicles, and equipment that were essential for European countries to reconstruct their economies. The Cold War era saw the United States maintaining a competitive edge over the Soviet Union thanks to its robust industrial base, capable of producing both consumer goods and military hardware simultaneously. The economic prosperity enjoyed in the 1950s and 1960s was built on the solid industrial foundation established during wartime. The legacy of this mobilization continues to influence contemporary times. World War II demonstrated that democratic societies can harness resources and coordinate efforts at a scale comparable to or surpassing totalitarian states when faced with existential threats. This period showcased the remarkable output potential of free people working collaboratively towards common objectives, outpacing forced labor systems in productivity. The war effort's industrial might laid the groundwork for enduring prosperity and global influence. The arsenal of democracy exemplified the innovative capabilities of its populace and the manufacturing prowess of American industry. An analysis of production figures across various categories underscores this achievement. During the war years, American factories produced nearly 300,000 aircraft and delivered 86,000 tanks to armored divisions. These tanks not only equipped American forces but also British, Free French, and other Allied armies through Lend-Lease agreements. While the Sherman tank had limitations compared to German heavy tanks like the Tiger and Panther, its reliability and ease of maintenance under battlefield conditions made it a formidable asset in sheer numbers. For every German heavy tank produced, dozens of Shermans were available, ensuring that for each Sherman lost, 3 more could be deployed as replacements. Although German tank crews might excel in individual engagements, they struggled to match the overwhelming production capacity of American factories. Additionally, 90,000 pieces of artillery were manufactured during this period. The artillery arsenal varied from lightweight howitzers that could be broken down for transport by mules to enormous railway guns capable of firing at targets far behind enemy lines. American military strategy heavily stressed the importance of overwhelming firepower. Forward observers were able to quickly direct intense artillery barrages onto German positions, a capability contingent on having an ample supply of artillery pieces and an endless flow of ammunition. The United States industrial base met these demands with efficiency. The volume of shell production was immense. Billions of artillery shells, mortar rounds, and small arms ammunition rolled off the assembly lines throughout the war years. Ammunition shipments crossed the Atlantic in convoys to keep up with the massive consumption required by American tactical approaches. Manufacturing 2 million army trucks significantly increased mobility on the battlefield. Previous conflicts saw armies heavily dependent on railroads for supply logistics. While combat units could advance beyond railroad termini, sustaining operations far from these infrastructure points was challenging. American forces in Europe and the Pacific achieved unparalleled maneuverability thanks to truck convoys that kept supply lines operational over vast distances. The Red Ball Express operation during the summer of 1944 exemplified this logistical prowess by moving massive quantities of supplies to forward units. This initiative involved approximately 33,000 personnel operating a fleet of 6,000 trucks on dedicated routes and reached its peak with daily deliveries of up to 12,000 tons of goods. Such an undertaking was feasible only due to the staggering production levels of American factories, which initially appeared excessive but proved indispensable. Small arms production paralleled that of larger equipment, with millions of M1 Garand rifles, M1 carbines, Thompson submachine guns, and Browning automatic rifles manufactured. These weapons not only equipped American troops, but also supplied Allied armies whose domestic production fell short. The adoption of the semi-automatic M1 Garand rifle just before World War II gave American infantry a significant edge over their adversaries, who primarily relied on bolt-action rifles for their frontline units. The Garand's 8-round clip and semi-automatic mechanism offered enhanced firepower. General George Patton famously declared it the finest battle implement ever created. However, its technical superiority was significant only because American factories were capable of producing enough Garands to arm every infantryman. The mobilization efforts extended well beyond military production. The nation's merchant marine saw a dramatic expansion to transport military cargo and sustain international trade. In addition to the 2 710 Liberty ships built, American shipyards also produced specialized vessels such as 512s and Victory ships capable of maintaining a cruising speed of 15 knots compared to the Liberty's 11 knots. Tankers were constructed to carry oil from sources in America and the Caribbean to supply European and Pacific theaters. Without sufficient tanker capacity, Allied mechanized forces would have been unable to operate due to fuel shortages. Standardized T2 tankers were mass-produced alongside specialized refrigerated cargo ships for food transport, troop transports to move soldiers, and hospital ships to evacuate wounded personnel. Each vessel type required distinct design elements and equipment, yet all were manufactured in large enough quantities to meet the growing demands of wartime logistics. Aircraft production reached nearly 300,000 planes encompassing a wide array of types. Heavy bombers like the B-17, the Flying Fortress, and B-24 Liberator carried out strategic bombing missions against Germany and Japan. Medium bombers such as the B-25 Mitchell and A-20 Havoc supported ground troops and targeted tactical objectives. Fighter aircraft including the P-38 Lightning, P-47 Thunderbolt, and P-51 Mustang provided air superiority and conducted ground attack operations. Naval aircraft operated from an expanding fleet of aircraft carriers. Transport planes like the C-47s and Skytrain delivered paratroopers into combat zones and supplied isolated units with essential supplies. Hundreds of thousands of pilots honed their combat skills through specialized training planes, each requiring distinct equipment and manufacturing processes. Despite these challenges, the industry managed to produce all necessary variants simultaneously. As designs evolved based on frontline feedback, the logistical hurdles in supplying raw materials to this vast industrial network grew increasingly complex. To meet military requirements, steel production surged while still fulfilling essential civilian needs. Aluminum output skyrocketed to support aircraft manufacturers. Copper shortages were so severe that the government had to borrow silver from its reserves to produce electromagnets for uranium enrichment at Oak Ridge. Japan's conquest of Southeast Asia severed rubber supplies, prompting a frantic effort to develop synthetic rubber just in time to avert critical shortages. By 1944, synthetic rubber production surpassed pre-war levels of natural imports, illustrating America's industrial adaptability and technical ingenuity under pressure. The workforce behind this production miracle came from unexpected demographics. Women, minorities, teenagers who left school for defense work, retirees returning to factories with their expertise, and disabled workers filling non-physical roles all contributed significantly. Every available worker was mobilized because the demand for full-scale production could not be met otherwise. Training programs educated individuals unfamiliar with industrial jobs in essential skills such as machine operation, welding, and aircraft assembly. High school students learned mechanical operations while housewives acquired welding techniques, and farmers were trained to assemble planes. The success of these initiatives hinged on their necessity. Winning the war required robust production capabilities, which in turn relied on a well-trained workforce. The tasks involved were arduous and frequently perilous. Factories ran continuously with 3 rotating shifts around the clock. Workers dealt with hefty machinery, hazardous substances, and extreme temperatures. Numerous industrial fatalities occurred during wartime due to accidents like falls from scaffolding, equipment breakdowns, explosions, and fires at defense plants nationwide. The pressure for rapid output sometimes compromised safety protocols. Employees tolerated these hazards knowing full well the implications of their efforts. Any delay in production meant additional casualties among troops stationed abroad. Those laboring in Detroit, Willow Run, and shipyards across the country understood that their contributions directly impacted the survival of their sons, husbands, and brothers on the front lines. This understanding fueled them through arduous hours, perilous conditions, and personal sacrifices. The financial burden of mobilization was immense. From 1941 to 1945, the federal government allocated roughly $300 billion toward the war effort, surpassing total expenditures from all previous years in American history combined. Defense spending reached a peak of over $80 billion annually in both 1944 and 1945, accounting for about 40% of the entire national economy dedicated to military purposes. Funding came through taxes, war bonds, and loans. Taxation rates rose dramatically during this period, expanding from primarily affecting affluent Americans before the war to encompassing a broader spectrum of workers. Payroll deduction systems were put in place to automatically withhold taxes from employees' paychecks. War bond campaigns urged citizens to support their government by purchasing bonds, which would be repaid with interest once the conflict ended. Despite significant government spending and high tax rates, inflation was kept under control through strict price controls and rationing measures. The Office of Price Administration set maximum prices for most products and services. Rationing helped ensure that scarce resources were distributed equitably rather than being monopolized by those who could afford to pay the highest prices. This combination of price controls and rationing prevented inflation, which might have otherwise resulted from full employment and government deficit spending. Workers in defense plants earned substantial wages but faced limited opportunities to spend their earnings due to scarcity of consumer goods and strict rationing on food and gasoline. Consequently, Americans saved money at unprecedented levels. These accumulated savings during the war years, when there was little available to purchase, became a significant source of purchasing power that fueled post-war economic growth. The mobilization of industry created opportunities for both entrepreneurs and existing businesses. For instance, Henry Kaiser, who made his fortune building Liberty ships during the war, had been a construction engineer prior to the conflict. Similarly, Howard Hughes significantly expanded his aircraft business during the war years, although his most ambitious project, the massive H-4 Hercules flying boat, did not fly until after the war's end. Countless smaller manufacturers found profitable niches by supplying parts to major contractors. Machine shops that had employed a dozen workers before the war grew into large factories with hundreds of employees. This economic expansion generated wealth that would support post-war growth and stability. The conclusion of the war brought about challenging transitions. Women who had worked in defense plants were often encouraged to relinquish their jobs to returning veterans. Many women felt resentment at being pushed out of roles they had mastered and found fulfilling. Their wartime experience, which included earning good wages and developing new skills, had fundamentally changed them. However, societal expectations after the war that these women would happily return to domestic life ignored the transformative changes they had undergone during their time in the workforce. Likewise, African American employees who had secured stable positions in defense sectors encountered fresh discrimination once hostilities ceased. Many minority workers discovered that their wartime advancements in employment and earnings were short-lived. These disappointments fueled social movements advocating for equality during the post-war era. The shift from war production to civilian manufacturing occurred more smoothly than anticipated. Car manufacturers swiftly resumed operations, with new vehicles rolling off assembly lines by 1946 despite persistent supply shortages. A surge in housing construction followed as veterans married and began raising families. The GI Bill enabled veterans to pursue higher education and obtain affordable mortgages for homes. This expansion bolstered the middle class and reshaped American society. Suburban areas flourished, with young families opting for single-family dwellings with yards, shopping centers, drive-in restaurants, and car-centric lifestyles becoming commonplace. The prosperity of the 1950s stemmed from wartime industrial growth and post-war economic policies that channeled wartime savings into productive investments. America's global economic supremacy influenced the world order after World War II. The United States emerged as the leading economic power globally. American currency became the international reserve currency, and U.S. companies expanded internationally. American products found markets worldwide. Announced in 1947, the Marshall Plan allocated billions of dollars to rebuild Western European economies. This initiative was beneficial for American interests by fostering prosperous trading partners and allies against Soviet expansionism. However, it was feasible only due to America's vast industrial capacity capable of meeting both domestic needs and international commitments. The Cold War competition with the Soviet Union relied on America's robust productive capabilities. The extensive military apparatus established post-war relied heavily on industrial capabilities that could concurrently cater to consumer demands and military requirements. Soviet officials recognized their inability to rival the productive capacity of the United States. As a result, their strategy focused on developing conventional military forces alongside nuclear weapons due to their limited industrial resources. Throughout the Cold War, America's strategic edge stemmed from its robust industrial infrastructure developed during World War II. The lessons gleaned from wartime mobilization profoundly shaped American business and governmental practices for years to come. This period highlighted that extensive coordination between government entities and private industry could yield outcomes unattainable through market-driven mechanisms alone. Techniques such as program management, systems engineering, and large-scale collaboration, which were earned during the war, were subsequently employed in various post-war initiatives like the Interstate Highway System, space exploration programs, and significant military hardware projects. This demonstrated that organizing vast technical undertakings became a defining American prowess. Technological advancements born out of wartime mobilization had far-reaching effects extending beyond military contexts. For instance, the proximity fuse, designed to enhance the efficacy of anti-aircraft weaponry, marked a pivotal milestone in miniaturized electronics. Earlier anti-aircraft shells required either direct hits or precise detonation at predetermined altitudes. In contrast, the proximity fuse incorporated a miniature radio transmitter and receiver within the shell itself. Upon nearing an aircraft, the reflected signal triggered its explosion, significantly enhancing the lethality of anti-aircraft fire. Given its critical importance, this technology was initially deployed exclusively over water to prevent potential adversaries from recovering and analyzing defective shells. During the Battle of the Bulge proximity, fused shells emerged as a decisive force multiplier against both infantry and armored units. Post-war, the miniaturized electronics derived from proximity fuses found applications in various sectors, including industrial controls and automation systems. Over time, these innovations contributed to the advancement of more sophisticated electronic devices. Additionally, radar technology, originally pioneered by the British before World War II, but perfected through American industrial methodologies, underwent significant refinement for mass production. Early radar systems were bulky, unreliable, and challenging to manufacture at scale. However, American engineers successfully redesigned them for efficient large-scale production while simultaneously enhancing their performance and reliability. Ships, aircraft, and ground stations equipped with radar enabled nighttime and poor weather operations that would have been impractical without visual navigation aids. Radar systems could spot incoming enemy planes and vessels, guiding interceptor aircraft to their targets. Post-war, the technology transformed aviation by facilitating routine all-weather flights. Weather radars helped pilots identify and circumvent hazardous weather conditions. Air traffic control radar was crucial for modern commercial aviation, allowing controllers to monitor numerous aircraft at once. Marine radars enhanced navigation safety and minimized collisions. The military's development of detection technologies became indispensable in peacetime transportation and commerce. Metallurgical advancements spurred by wartime requirements had enduring civilian applications. Aircraft manufacturing required aluminum alloys that were both stronger and lighter than pre-war materials. High-temperature alloys were essential for engines operating under extreme conditions, while specialized steel alloys were needed for armor plate. The research into military-grade materials propelled the entire field of metallurgy forward. Post-war industries benefited from wartime developments in materials science. During World War II, the aluminum industry saw significant growth and continued to be a major sector afterward. As production costs decreased due to improved processes developed during mobilization, aluminum found wider use in construction, transportation, and consumer goods. Chemical industries expanded dramatically to meet military demands. Large-scale production of explosives required vast amounts of nitrates and other chemicals. Although never used on the battlefield, poison gas manufacturing necessitated substantial chemical facilities. The production of synthetic rubber surged when natural rubber supplies were cut off, eventually becoming a permanent industry. Pesticides like DDT, initially developed for military purposes to protect soldiers from disease-carrying insects during wartime, later found significant agricultural applications after the conflict ended. The large-scale manufacture of penicillin to treat injured troops laid the groundwork for today's pharmaceutical sector. World War II spurred the development and mass production of various medications that would save countless lives in peacetime. Techniques used for manufacturing military equipment permanently transformed American industry. Prior to World War I, Henry Ford had introduced the moving assembly line for automobiles. During the war, these techniques were refined and applied to more intricate products than cars. The experience gained from constructing bombers, tanks, and ships influenced post-war industrial practices across all sectors. Inventory management systems, quality control methodologies, and production scheduling procedures developed during wartime became standard business protocols. Efficiency improvements achieved under wartime conditions continued in peacetime, significantly contributing to American manufacturing supremacy after the war. Training methods devised to rapidly impart industrial skills during wartime permanently altered education and workforce development. Before the conflict, skilled trades required long apprenticeships. The exigencies of wartime production necessitated quicker training methods. Technical schools created accelerated courses that quickly taught specific skills. Industrial programs brought education directly to factory floors through on-site instruction. Visual aids, hands-on practice. Unstructured curricula replaced the traditional mentoring approach. These innovations proved successful and were retained post-war. Community colleges and vocational institutions adopted techniques developed during mobilization. The GI Bill, which enabled millions of veterans to attend college, fueled a dramatic expansion in educational capacity. Universities expanded rapidly to accommodate the influx of veteran students, leading to a permanent increase in American higher education facilities. The experience of managing large-scale enterprises during wartime had a significant impact on management theory and practice. Prior to the war, most American businesses were small, and even larger corporations operated with minimal formal planning and coordination. The demands of military production necessitated the development of advanced management techniques. Techniques such as critical path analysis, program management, systems engineering, and others were either developed or refined during this period. Institutions like Harvard Business School studied these wartime practices and integrated them into their teaching curricula. Managers who honed their skills during mobilization brought these lessons into peacetime industries, influencing American business culture for decades. The social impact of the mobilization was equally significant. Women working in defense plants challenged traditional gender roles. Although many women left industrial jobs after the war, they had proven their capabilities, and this could not be overlooked. The image of Rosie the Riveter, or partly a piece of propaganda, reflected real accomplishments by women during wartime. Post-war society could no longer revert to pre-war gender norms once women had demonstrated their proficiency in demanding industrial roles. The civil rights movement that emerged in the 1960s and 70s drew partially from memories and lessons learned during World War for African Americans. The Great Migration, which moved black workers from rural southern states to northern cities during and after World War I, accelerated further during World War II. Industries such as defense manufacturing in Detroit, Chicago, Los Angeles, and other major urban centers offered wages that were far superior to what was available in the segregated South. While discrimination persisted in these northern cities, new opportunities existed that did not exist in the South. The experience of contributing to the war effort while still encountering racial discrimination intensified demands for civil rights. Black veterans who fought against fascism abroad returned home less willing to tolerate racial oppression at home. The civil rights movement that reshaped America during the 1950s and 60s found inspiration partly from these wartime experiences. The economic boom that started in the late 1940s and lasted until the mid-1960s was significantly rooted in the groundwork laid during wartime. The industrial infrastructure established during the conflict continued to operate effectively after the war ended. Investments in power plants, transportation systems, factory facilities, and other critical infrastructure remained operational and productive assets throughout peacetime. The skilled labor force trained through wartime programs sustained its productivity, while management skills honed during the mobilization were applied to civilian enterprises. Technological innovations originally developed for military use found widespread applications in daily life. Workers' accumulated savings from wartime provided a significant influx of capital for reinvestment. These various elements coalesced to foster an unprecedented era of broadly shared prosperity in American history. The post-war international order mirrored the dominance of American industry. The Bretton Woods system solidified the US dollar as the world's primary reserve currency, underpinned by America's manufacturing prowess. Institutions such as the International Monetary Fund and World Bank, based in Washington, D.C., facilitated global finance and development. The Marshall Plan leveraged American resources to rebuild Western Europe, while NATO offered security assurances backed by U.S. military might, which itself depended on American industrial capabilities. Japan's economic resurgence and transformation into a major power happened under the guidance of American occupiers who applied lessons learned during their own wartime mobilization. For several decades after the war, the global economy was centered around American industrial and financial supremacy. The Cold War rivalry with the Soviet Union tested America's industrial strength in novel ways. A substantial military establishment was maintained post-war, larger than any peacetime force in U.S. history, necessitating ongoing support from industry. Aircraft manufacturing, although below wartime levels, continued at considerable rates. Shipbuilding also persisted, especially for naval vessels like aircraft carriers and submarines to expand the Navy's capabilities. The Korean War, which began in the early 1950s, prompted a renewed mobilization effort, albeit on a smaller scale than World War II. The space race, which commenced in the late 1950s, required significant industrial and technological advancements that were heavily influenced by wartime experiences. The Apollo program, culminating in the moon landing of 1969, utilized systems engineering and project management methods that originated during World War II. America's eventual triumph in the Cold War, achieved without direct military confrontation between superpowers, was a result of industrial and economic advantages derived from World War II mobilization efforts. Despite possessing vast military forces and nuclear arsenals, the Soviet Union could not match American production capabilities across all sectors. While Soviet citizens faced ongoing shortages and limited access to consumer goods, Americans continued to enjoy increasing affluence. This stark contrast between Western prosperity and Eastern scarcity ultimately weakened Soviet legitimacy. The collapse of the Soviet system in 1989 to 1991 was a reflection of economic competition that had been lost decades prior. The enduring legacy of World War II industrial mobilization continues to shape America and the world today. This period demonstrated that free societies, when faced with threats, could organize and mobilize just as effectively as totalitarian regimes. It underscored the compatibility between democratic governance and market economies in supporting large-scale coordinated efforts. Moreover, it highlighted that diversity was a strength rather than a liability, as women and minorities played crucial roles in production endeavors. The war revealed unsuspected capacities within ordinary people who achieved extraordinary feats when necessity demanded. These lessons remained pertinent long after the conflict concluded, influencing American responses to subsequent challenges and shaping national self-perception. Many factories from that era have since been repurposed or dismantled. For instance, Detroit Arsenal Tank Plant ceased operations after producing tanks through the Korean War period. Although parts of this extensive facility still exist, no more tanks roll off its assembly lines today. Willow Run transitioned to automobile production following the war and later manufactured components for other manufacturers before being demolished despite preservation efforts. Shipyards that once launched thousands of Liberty ships also closed as post-war demand for merchant vessels waned. Physical remnants of the mobilization have largely disappeared, but the accomplishments remain etched in historical records and statistics that continue to astonish. The final tally highlights the enormity of the accomplishment. American factories churned out roughly 959 military aircraft throughout the conflict. This marked a significant surge from fewer than 3,000 planes produced in 1939 to an astounding peak of over 96,000 aircraft manufactured in just 1 year, 1944. The transition from President Roosevelt's initially daunting objective of producing 50,000 planes within a year to the actual output that far surpassed this ambitious goal underscores the power of a coordinated national effort. This awakening giant showcased its industrial might, which played a crucial role in shaping the war's outcome.